Okay, in this question you're asked, how many grams of magnesium chloride are produced in the end? It's an interesting question actually, because if magnesium chloride is aqueous, it'd be pretty hard to weigh it because it's dissolved in solution. Actually, it's dissociated in solution. But theoretically, we could figure out what the mass of that is. Okay. Oh, and we're starting with moles. Good. So I've got 3.38 moles of magnesium, 3.38 moles of hydrochloric acid. So I have to figure out which one is the limiting reagent. And then once I've picked that, then use stoich to get to magnesium chloride. So my solid liquid gas thing, moles. So I'm starting at moles here. And then I'd have to convert to moles. And this side will be my limiting reagent, which I don't know what it is yet, but that'll be my limiting reagent. So step one will be to there, and then step two will go over here, and that's my magnesium chloride. Okay, so to figure out which is the limiting reagent. So looks like you took mercury to start with. That's what I would use. 3.38 times 2. So if I have 3.38 moles of magnesium, I need 6.76 moles. So this is what I need of hydrochloric acid. So if I want to use up all of this magnesium, it's going to take that many moles of hydrochloric acid. But then I compare and I look and I say, well, I don't have near enough to do that. So if I don't have near enough, that means that this one that I don't have enough of must be the limiting reagent. It'll get used up first. Okay, hopefully that makes sense. You could do it this way too. You could do this one and say you need that much hydrochloric acid. You could also go the other way. So you could say I have 3.38 moles of hydrochloric acid and do my mole ratio. So 2 moles of hydrochloric acid react with 1 mole of magnesium. So when you divide that, you get 1.69, I think, moles of magnesium. These cancel. Whoops, not the 2, but that cancels. So that means if I use up all my hydrochloric acid, then that is going to require this many moles of magnesium. And you look up at the top there, and you got plenty. You can cover that. So that means you've got too much, not too much, but you've got excess of the magnesium. So the limiting reactant must be the hydrochloric acid. Hopefully that's making a bit of sense. So you're using this number here, what they gave you, and then you're using the mole ratio to figure out here how much magnesium you would need if you used up all the, hold on here, if you used up all the hydrochloric acid, right, which I had 3.38 moles of it. So if I have 3.38 moles of hydrochloric acid, according to the mole ratio, I'd need this many moles of magnesium. And when I take a look, I've got plenty of that. I've got tons. Therefore, the thing that is the limiting reagent is the hydrochloric acid. And then you do your do your stoichiometry now. So we figured out the limiting reagent. Now we do stoich. Let me do another question with you and just see if, as I go through it, maybe you might want to pause and just see how it goes. Okay, here's another limiting reactant question I borrowed from the Khan Academy. So I'm reacting copper with silver nitrate, and it produces silver solid and copper 2 nitrate. So the question is how many grams of silver, so mass of silver, I want to know, can be produced if you have 5 grams of copper and 1 gram of silver nitrate. Again, it's sort of funny they use grams there because silver nitrate is a solution. Copper is a solid, so that makes sense. But okay, theoretically we could extract it from the water and weigh it. Okay, so how many grams of silver will be produced from that? So I take a look, and here I have a mass, and here I have a mass. And so I have too much information on the left-hand side. So I'm not sure which one is my given and which one, well, I know which one is my asked. That'll be that one. So when I do my stoichiometry, I know I'm going to have to go from a solid to moles. Step 1, step 2, and finally back there to step 3. I know this side here is silver, but this side I don't know. It could be copper or it could be silver nitrate. So I have to figure out the limiting reagent. So I need to determine how many moles of each are, and then you pick one of those moles and figure out how many moles of the other you would need if you wanted to use it all up. And that's where you make the decision on whether it's limiting or not. So let's do it. So copper. So find moles of copper. So moles are equal to mass over molar mass. Mass is 5 grams. Molar mass, I think, is 63.55 grams per mole. Calculator. Okay, 5 divides 63.55. So this is 0.078678, etc. moles of, not silver, copper. Of copper. Okay, that's how many moles. And remember, we have to compare moles to moles. Can't compare grams to grams. All right. Now let's figure out the moles of the silver nitrate. This one might be harder because I don't know what the molar mass of silver is. Only 1 gram divided by, let's do that. So silver nitrate. So I have 1 silver, and nitrogen is 1401, and 3 oxygens are worth 48. Silver, 107.87. Let me pause and check. Yeah, that was right. 107.87. Let's add those. 107.87 plus 14. I should have done it in my head. Plus 48. 169.88. So this is 169.88 grams. So 1 divided by that gives me 0.005865 moles of silver nitrate. Okay, so that's how much I have. So I've got this much silver nitrate and I have this much copper. So now I'm going to pick one of those and see, according to my mole ratio, 1 to 2, how much of the other one I would need. And then I compare. Okay, so let's do the copper one. So copper. So I have 0.07868 moles of copper. So if it were to react entirely with the silver nitrate, it'd be 1 copper is to 2 moles of silver nitrate. So I have to double that number. Oh. Okay, so I have to double that number. So that gives me 0.157356, etc. So I have this much copper. If I use it all up, it's going to require that much silver nitrate, that many moles of silver nitrate. Now I compare. Now compare. My calculation says that I need 0.157356 moles of silver nitrate in order to react all the copper. But how much do I have? This amount right there, 0.005885 moles. That's how many moles of silver nitrate I actually have. But this is how much is required to react with all the copper. I don't have nearly enough. So this is how much I have. This is how much I need. I'm way short. Therefore, this silver nitrate is the limiting reactant. Okay, so therefore silver nitrate is the limiting reactant. So let's continue and do the rest of the question. So my first step is to convert moles or grams into moles, and I did that already. So since silver nitrate is my thing, I don't worry about this copper. Here's another copper. Don't worry about that at all. And this stuff here, its purpose was just to figure out the limiting reactant. I don't need to use that information anymore. But I do want to use this information because that is how many moles of silver nitrate I have. So that's step one right there. I'll just put the number down here below. So step one, mass of silver nitrate to moles of silver nitrate. Done already. I know it's 0.0058865 moles. That's a 6. Okay, step 2 is to take moles of silver nitrate and convert it to moles of just plain old silver. Okay. The ratio is 2 to 2. Nice. So the ratio, it's a 2 to 2. So therefore, the moles of just silver are equal to the moles of the silver nitrate, and that is 0.0058865 moles. That's step 2. So then step 3 is to convert that number of moles into grams. So take your moles of silver and convert into mass of silver. Formula, mass over molar mass. Multiply both sides by the molar mass, you get that. So the moles you have are 0.0058865 multiplied by the molar mass of just silver, not 63, that's copper. Silver is 107.87 grams per mole. I should have written moles here. So if I multiply those two, 0.005865 times 107.7 equals 0.634976 grams of silver. Let's check sig figs. In the question, 3, 3. And all my molar masses were 3. So I need to go to 3. 0.635 grams. That's how much silver you'll get out at the end. You could also ask the question, since that was the limiting reactant, so this one gets all used up because it's the limiting reactant. So you could ask and say, well, how much copper is going to be left over too? And that we did some of those questions in class. But okay, hopefully that helps you a little bit more with limiting reactants.